Example 3. Find the area of the region R between the graph of f of x equals 1 over square root 9 minus x squared and the x-axis on the interval -3 to 3. And it can be represented by the definite integral from -3 to 3 of the function 1 over square root of 9 minus x squared with respect to x. And this function is an even function. We can use the even function property of the definite integral from point a to negative a to a by rewriting as the twice of a half, which is from 0 to 3 of 1 over square root of 9 minus x squared with respect to x. Once we get into this form, we can see that the function is continuous at the lower limit 0, but not continuous at the upper limit x equals 3. From the real number line, to represent the interval of integration from 0 to 3. Continuous at 0, but not at 3. Use the point B on the left side of the 3. Take the limit as b approaches 3 from the left. Therefore, this improper integral is written as 2 times the limit of the definite integral from 0 to b as b approaches 3 from the left. The integrand is 1 over square root of 9 minus x squared with respect to x. This integration, we see the pattern of the number squared minus the variable squared, which is 3 squared minus x squared for our case. We're going to use the trig sub technique. And then draw the right triangle diagram. Angle theta. When you have the difference of the two squared, the first term squared would represent the side of the longest side, which is the hypotenuse. So in this case, we have the hypotenuse as a 3. And x is the opposite. Therefore, the adjacent is 3 squared minus x squared, which is 9 minus x squared. Form the relationship of the x and 3. X over 3, which is the opposite over hypotenuse of the sine function or sine theta. We can write x as 3 multiplied by sine theta. Find differential x, which is 3 times cosine theta d theta. Therefore, the integral of 1 over square root of 9 minus x squared with respect to x can use the use of technique by rewriting everything in terms of theta and the trig function. The dx is 3 times cosine theta d theta, and the denominator as the square root of 9 minus the x squared, which is 9 sine squared theta. Simplify the denominator and write it as the common factor 9 times 1 minus sine squared theta under the square root with respect to theta. Recall 1 minus sine squared is the cosine squared theta. So then the denominator becomes 3 multiplied by cosine theta d theta. It's very nice that they are both reduced. Now we have to find the antiderivative of 1 with respect to theta, which is theta. And from the relationship of the x over 3 and x in 3, so we can see this as theta equals the inverse sine of x over 3. Back to the main part of the integration. So the improper integral is 2 times the limit b approaches 3 negative. The antiderivative that we just got is the inverse sine of x over 3. Evaluate from 0 to b. Substitute the upper limit, the inverse sine of b over 3 minus the substitution using the lower limit, which is the inverse sine of 0 over 3 or just 0. The value inverse sine of 0 is 0. For the inverse sine of b over 3, that approaching the inverse sine of 1 negative. And inverse sine of 1 negative, think about the graph of the sine function. It approaching 1 when it approaching pi over 2, but 1 negative, that means from the left side of negative. So that means this value approaching pi over 2 from the negative side or approaching pi over 2, we can say that. Then the limit value becomes pi over 2 multiplied by the coefficient 2. The answer is pi, which is the finite number. Example 4. Find the volume of the solid of revolution of the region bounded by the function f of x equals 1 over square root of x times log x and the x-axis on the interval to infinity revolved about the x-axis. From the graph, we're going to find the volume of the solid from revolving the area under the graph from point 2 to infinity about the x-axis. This one we are going to use this method. So we're going to need the radius. Let's make a partition at the position x for x between 2 and infinity, and the dx is the thickness of the disk. The volume is the integral times pi times the radius squared times the thickness dx. In this case, the radius or the r is the height of the function, which is the f of x equals 1 over square root of x times natural log of x. The integral from 2 to infinity. Now we write it as pi multiplied by the integral from 2 to infinity of the r, which is the 1 over square root of x times natural log of x, the quantity squared with respect to x, or pi multiplied by integral from 2 to infinity of 1 over x times the natural log of x quantity squared with respect to x. And this is the improper integral where the upper limit is in the infinity form. Take the limit of the definite integral from 2 to b as b approaches positive infinity of the integrand 1 over x multiplied by natural log x squared with respect to x. Use the use of technique by letting u be natural log of x, du is 1 over x dx. The integral of 1 over x times log x squared with respect to x equals the integral of 1 over u squared multiplied by du, or the integral of u to the negative second with respect to u. The antiderivative will be negative u to the negative first, which is negative 1 over u, where u is natural log x. Bring it back to the main part of the problem. We have pi multiplied by the limit as b approaches infinity. The antiderivative now is negative 1 over natural log of x. Evaluate from 2 to b. Bring negative outside together with the pi. So negative pi multiplied by the limit as b approaches infinity of 1 over natural log b minus 1 over natural log 2. For 1 over natural log b, b approaches infinity. This term approaches 0. Therefore, the answer is negative pi multiplied by negative 1 over natural log 2, or pi divided by natural log 2 as a result.